Okay, so now we're spending the last day on permutations, but now we're going to complicate things quite a bit by putting restrictions and repetitions in there. Now I'm going to teach you some exact strategies to get through each specific type of question. Now, you'll have to obviously learn these strategies and not get them mixed up. The best way to do that is get them all side by side on one page. Do this when this happens. Do this when this happens, okay? That is organizing your thoughts, okay? That's what that study sheet is for. People who do not have their thoughts or all their rules organized, all their thoughts organized, and can differentiate between things do not do well in my unit exams. Because every time I talk to them after, I get them to tell me their rules, and they got that one mixed up with that one, and they've got this one. Like, you didn't even know what you were doing before you went into this test. And it's quite obvious, right? And the last test, I think, was an excellent example. If you knew your rules, you were going to do well. If you had them mixed up, if you're like, oh, I don't know, if it's even and negative, I think you start low and low, yeah, and did a few questions with that way, you would have probably messed up 3 or 4. So this one has way more rules, but a lot of these I have, I shouldn't say made up, but found to be the simplest way to do these and most understandable, okay? So as we're going through these, you're going to find that they do sound very obscure, very complicated, very, whoa, how would I ever do that? And I'll say, whenever you have this scenario, do this, okay? And then hopefully you've got that as a rule. Now, restrictions mean, John can't beside Jane, this has to be the first letter. All the vowels must be together. K and C must be at the beginning and the end. Those are called restrictions. Like, I'm trying to give you a few things that you have to adhere to, and then the rest is fair game. Okay? So let's look at the word oranges. Now, what you always want to do when you start these, which can be disastrous if you mess this up, is count the number of letters. What do you got? 7? Count them backwards, count them forwards. Make sure you have 7, okay, if you are going to use 7. Because I think it's fair to say, if you thought there's 8 letters, A, B, C, D are probably going to be wrong. So, as it happened, every single year I mark this exam. Okay? At least one of you will count the number wrong and do your questions with it. Okay? So it kind of sucks when the grade 1 stuff is interfering with the grade 12 stuff. But it does happen. Happens to me, happens to everybody. Okay? So what is the total number of arrangements I can make if there's absolutely no restrictions? How would you do this one? Okay, that is one way. 7, pick 7. That's one way. What's another way? No, that's the answer. What are 2 other ways to do this one? Yeah, the fundamental counting principle. Go 7 blanks. 1, 2, 3, 4, 5, 6, 7. And then go 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, what is another way? 7 factorial. When am I allowed to use 7 factorial? When what? No, but we did that. Okay? What if I just said, I looked at this question, I'm going to go, that's 7 factorial. Why? If you can't answer why right now, that might explain a couple things. Why can I use 7 factorial? No, that's not why. If I was allowed to pick 3 of these, that's still no restrictions. But we know that because we did the fundamental counting principle. What is the rule when you get to use 7 factorial? I did it on your notes yesterday. When you use all of them, that's the only time. If there's 7, if there's 7 objects and I get to use only 3 of them, is that a restriction? It's not a restriction. That is 7p3, or 7 times 6 times 5. A restriction is when one of the blanks you put rules on. 7, if I'm only allowed to pick 3 of them, that's not considered a restriction, okay? That's 7p3. So you can only use 7 factorial when you are picking all of the items. Now again, would you get that one wrong on an exam? You remember it now. I got you. You're going to get it right tomorrow because you still remember this, but you will not remember it in 2 months. Now, with each one of these, you do get the answer 50-40, okay? Now we're starting with our first restriction. The first letter must be an N. Now, with these, I find that the fundamental counting principle is the best whenever you get restrictions. So, and it makes the most sense. So how many blanks would I draw if it's the fundamental counting principle? 7, right? 1, 2, 3, 4, 5, 6, 7. Always start with your restrictions. This must be an N. So there's a 1 there. How many choices for the next one? So 6, 5, 4, 3, 2, 1. So if you just went to the solution manual, it's just going to have this answer, 6 factorial. Well, now you could look at it and go, oh yeah. But if I just wrote 6 factorial, and then we went on to C, I know I'd be having people going, what? How did you get 6 factorial? Now it's obvious by looking at it. It's 1 times 6 times 5. So it's 1 times 6 factorial. And the other way you can look at it too is we're actually taking N out of the pool. We're taking it out of the selection. Therefore, I really only have 6 to pick from to start. You've heard of a pool is like what you're looking at. Like if you're doing a hockey pool, that is all the hockey players, and I get to pick 10 of them, who's ever going to get the most. Now, why am I not going to pick Gretzky? He's not in the pool. Okay? So don't include him. So N is not in the pool. Okay? So usually, or who would I not pick? Especially if I was picking, hockey pool, and there's someone that's got like a broken leg. With this short season, I probably wouldn't pick him in my pool. I would take him out of the pool. Okay? Or back in the 80s when Gretzky was playing, he wasn't allowed in the pool. Okay? Because he was such a dominant player that if you had him, you won for sure. You would win the... And so it was kind of like, okay, guys, how about we say he's not in the pool? And when a true hockey pool is you get a bunch of people sitting together, here's all the players, and once you pick a player, he's no longer in the pool. So how would you decide? You would, pull cards, whatever, see who goes first. And that's why Gretzky wasn't allowed, because if you got, it was just a no-brainer. You picked Gretzky, you would win the hockey pool. You could have 3 guys injured and 2 guys leave the country on your hockey pool, and you would still win with Gretzky. So sometimes you said, okay, he's just taken out of the pool. How many do we have to pick from now? Okay? Now, what about the vowels must be together in the order A, O, A, E? Now, what this is saying is this is like, I want you to pick, pretend that these are all kind of little discs or whatever in a bag, and you're pulling it out. And one is now going to be an OAE bag, or disc. So how many groups or how many discs do I have together now? Okay, what would the other ones be? What are other things I can pick out of the bag? An R. What else? G. Well, we should probably... do N, right? N and G and S. Do you understand what just happened? They made OAE one entity. They're together. So how would I do this one? How many things can I pick? 5. So it's 1, 2, 3, 4, 5. So that would be 5 times 4 times 3 times 2 times 1, which is 5 factorial. So there's actually 5 things now once you say this is a group. So now you should have on your study sheet, when would you use this? Now, this is very different than one we will do later. And they're together in order. What if I said they could be any order? Would this be the answer? No. It changes it by one word. So I would have on my study sheet this one, and how is it different than this one? And that's how you start to really learn this stuff. When you can articulate why this way is different than this way. Because if I said, how are these two different? You're like, I don't know. Okay, well, there you go. There's a big gap right there that you don't know. How about these two? Oh, no, I don't know the difference of those two either. Okay, making sense now why you got your test mark. Okay, so can you see similarities, differences? Are you writing little notes? This is where they're similar, but this is where they're different. Okay, that is the, I guess, responsibility you have to come up with when you're making a study sheet. It's not just throw a bunch of crap down and hope I get to use it. Okay, it won't work, especially on this unit. Now, how many arrangements of the letter brains if the vowels must be together? So what have they done? They grouped what letters? A and I. So AI will be like one thing. And then you got B, R, N, S as another one. So how many ways would that one be? 5 factorial. Now why is this one different from C? It also could be IA. So that would be 5 factorial. So I'm saying it could be AI or IA. But that thing can move in all different. Now, what would I do with these two answers? Why? Because it's an or. Because it could be this or that. Can it be that and that? No. It can't be both of those at the same time. Okay? And usually means at the same time. So that or, so you would get 120 plus 120 equals 240. Now here's the way that I always do them. Because with two of them, I would have 2 arrangements. If I had 3, how many arrangements would I have to do? If there was 3 letters, A, I, and E, how many different? 6. How about if it's 4 letters? Good. So, can you come up with a formula or a way to do grouping questions where the letters can be in any order? It's not so easy, is it? Okay. You gave us the answer. Can you articulate how to do any single? Because we got 2, we got 6 when it was 3, and we got 4 factorial. So no one in this entire class could come up with a formula for how to do. Okay, well, tell me another way I could have done this quicker. What's another way to write 5 factorial plus 5 factorial? Could you go 5 factorial times 2? Okay. Now, if there was 3 letters, I would have gone 5 factorial times 6. If there was 4 letters, I would have went 5 factorial times 4 factorial. So after that, none of you can see a way to be able to do these. Graham, what do you think? See any way to do these? Okay. I guess let's keep moving here. What if the letters K, C, and N must be together, but not in that order? So the kitchen, how many letters are there? How many letters in kitchen? 7. Okay, so K, C, and N are a group. How many? How many objects do I have now? I would have that plus I plus T plus H plus E. Okay, I would have 5. Okay, and because K, C, and N can be any order, what should I multiply it by? 6. What's another way I could write 6? Can anybody gain a generalization now? So if I said if kitchen had another, like an O at the end, and I said arrange those 4 vowels, how would you do this one? Okay, what's another way to write 2? Come up to the top here. What's another way we could have wrote 2? What else equals 2? 2 factorial. Can you guys see any generalization yet? Yep. See how these are 5 ways this can be arranged? That's 5 factorial. Within the group can be arranged 3 factorial. So it's the number of groups times the number of ways it can be arranged in that one group. Yep.
So wait, how did you get the 5 factorial to 6 again?
Well, this can be, KCN, we know can be, see this how AI, we knew it could be done 2 ways. This we would have to do 6 ways, right? KNC, right? And then we'd have to do, so we know that from doing those 3 letters in the last 2 examples, or last 2 days, right? So I've come up with, and it always works, take the number of groups and multiply it by the number of ways I can do this within the group. Yes? Because last day, remember we did cat, and we did those 3 letters of that person's, and when you have 3 things, how many different ways are there to come up with it? 6. So I could have done this. See how I did AI and IA? That one's easy. When there's 3 things, I have to go KCN, KNC. Then I'm going to have to go CKN. Remember that? Okay, so that's from using learning of last class. But here is the faster way. It's the number of groups times, okay? Now, hopefully you've written that down, a rule to do these. And if not, yeah, you're going to have to give those up on the diploma or the test. They could give one. Like, do you see how fast the question that is? That is a question they could give you in the diploma. Your calculator's not saving you. You just have to know what you're doing. They are fast. These 4 questions in the diploma will be the 4 quickest questions you do. Okay? Trust me. And These are the ones you'll probably doubt the most when you're finished your diploma. So you're going to come back and you're going to do it a different way. You're going to maybe do it the long way. You're going to think about it backwards, upside down, inside out. Make sure you counted the letters right. All those things. Okay. So when you come out of the diploma, you aren't feeling, I wish I would have checked those over. Like I had no idea what I'm doing. Or I did it long form. I did in the back of my sheet. I got 6 of them and this and this. Now this one here. How about the vowels must not be together? How would you do that? What is the comp? Yep. Right. Okay, so anyone in this class, can we do this one? The vowels must not be together. Cody, you got nothing back there? How would you do this one? The vowels must not be together. What's the opposite of vowels must not be together? That's called the complement. In mathematics, the complete opposite is called the complement. Now, if I knew when vowels, do I know how to find it when vowels are together? I know how to do that. So that's not hard anymore. If I know all the ones that are together, how am I supposed to find all the ones that are not by knowing that? How about if I find all the possible cases and minus when they are together? Should that not give me when they are not together? How would I find out all the different arrangements? 7 factorial. So we're going to do no restrictions minus the complement. So do you see already I've given you a different strategy. This is what you do when they're staying in the same order. This is when you change the order. This is when they say must not be together. Do how we would do it if it was together. Now, the way not together would be 7 factorial. Now, who can tell me what would be the way to do this when they are together? How many groups would there be? So IE are going to be together. So how many groups are there? 5? No, because there's IE and then so that's 1. K, T, C, H, N. So there's 6 groups, right? So 6 factorial. How many ways can I arrange it in the group? 2 factorial. And that works out to 3,600. Okay, I actually didn't give the answer to this one. This is 720. Okay. Now, how about this one? How many ways can 3 girls and 4 boys be arranged in a row if 2 people of the same gender cannot sit beside each other? You don't want to get fleas. So we made sure. Spread them up. Any guesses? Okay, now when in doubt, what should you always try and use? What's that thumb? What should you always use when in doubt? I told you this works for the fundamental counting principle all the time. If you're arranging them in a row, can we not make the row? There would be 1, 2, 3, 4, 5, 6, 7. Now, if you're ever in doubt for a perm, make sure you are doing this. Now, there's something that has been given to you that is quite significant within that you have to be able to deduce to be able to go on with this. How would it be arranged in this row? It would have to be boy, girl, boy, girl, boy, girl, boy. Do you understand it couldn't be the other way? So all of a sudden, you can now, let's just do the boys. How many boys can sit here? 4. In the next one, 3. Next one, 2, and then 1. Okay? Now, how about the girls? How many could sit in the first one? 3, 2, and 1. And all you do is multiply these two together. Does this make sense? Now, if you went to the book and all they had was 4 factorial, 3 factorial, does that make sense? It does now. Do you see how there's a 4 factorial in there and a 3 factorial within? But if all you saw was 4 factorial, 3 factorial, I know people would be like, what? Okay? So, sometimes just seeing the answer is very confusing. But if you do it using the fundamental counting principle, it will make sense, and it's still not that inefficient. You may think, oh yeah, that takes way longer than 4 factorial, 3 factorial. Well, believe me, 4 factorial, 3 factorial, you probably never come up with until you saw this, and then you can see it's in there. Now, what if you have 6 actors and 8 actresses? They're available for a play with 4 male roles and 3 female roles. How many different cast lists are possible? Now, this one, would it be a com or a perm? Is order important? Maybe if I had everybody playing mushrooms, right? Because they're like horrible actors and I need to put them somewhere. It's like the grade 1. You know, the kids that are playing clouds and mushrooms and stuff. So, but they're all for different roles. So is order important? It is. Ask anybody that's trying out for a play, why is it so great getting the lead role? Sucks, you got more lines to memorize. Oh, there's nothing good about it, right? People care which role you get. So, how would I solve this one? Any ideas? Am I picking 6 males or 3 females? Or and 3? It's and, not or. Okay, and then 8p3. So it's 6 possible males, I'm picking 4, and 8 females to pick from, I'm picking 3. Now, how could you do this using the fundamental counting principle? How many male roles am I looking for? 4. How many choices for the first role? How many for the next one? 5, 4, 3. Times, let's do the female roles. How many am I looking for? 1, 2, 3. So how many in the first one? 8, 7, and 6. And do you see why this is 6p4 and this is 8p3? Like, hopefully you're seeing what the fundamental counting principle looks like towards the permutation, right? There's 8 to pick from. and 1, 2, 3. That's where the 3 comes from. Okay? You need to start seeing these. And again, when I took this unit in high school, I was never told all this stuff. You just kind of have to figure it out on your own. Yep. Because I am picking 6 male roles and, or sorry, 4 male roles and 3 female roles, not or. Okay, and is always times, or is plus. So if you said, I'm either going to pick 4 male roles or 4 female, then I would go plus. Okay, let's start talking about repetitions. Now, when you have the word rows, and you're finding out all the permutations for rows, you see them all here. Now, what's a faster way to figure them out? Come on, you guys. How do you figure out how many? You can go 4p4 or 4 factorial. I'm using all of them, right? Now, what about if we changed rows to Ross? And I said, find out all the arrangements. Well, you have ROSS, and if you take those 2 last ones and change them, do you see how we get a duplicate? These 2 are not unique, so that one would be taken out. Okay, now the next one we have an RSOS. Is there another time that pops up? Over here. How about an RSSO? Yeah, over here. You see how ORSS, and then there's ORSS in the bottom. Okay, so those are not unique, so they're taken out. So the way you deal with duplicates is, how many duplicates are there? Or how many? This is a duplicate, right? So what you do is you take the number, if there was no repeats, and divide it by the number of repeats. What's 4 factorial divided by 2 factorial? You should be able to do that in your head. 24 over 2? It's 12, right? So if there's a repeat, so there's 2 letters that are repeated, you put that down. There are 2 letters repeating. Now, how about if it was changed to RSS? With no restrictions or no repeats, you would do 4 factorial, and that would be divided by 3 factorial, which gives you the answer 4. So the next page is the formula to be able to deal with repeats. It is n factorial divided by a factorial, b factorial, c factorial. Now, those ABCs, that depends on the number of repeats there are in the word. It could be d factorial even, or just a and b, or just a. Okay? Now let's get going so you can see how this works. Vancouver, the first thing you need to do is count how many letters are in it. Do not screw this step up. Do it 4 times if you have to. Do it frontwards, backwards, start from the middle, go out twice. Do whatever you can to make sure you can guarantee that's the same number of letters. How many? 9. Okay, so there's 9 letters. Circle that. Now, let's do all the repeats. Tell me what are repeats. Can't hear you. 2 V's. Circle it. What else? Actually, we could even do this. Let's go over. That's 2 V's. What else? Anything else? Okay, so then you just go 9 factorial over 2 factorial, which is 181,440. Okay, let's do B now. How many letters? Okay, so there's 12 letters over. Okay, you got 2 M's. Slow down for me. 3 A's and 2 T's. So this is the same thing as 12 factorial over 2 factorial, 3 factorial, 2 factorial. And that's 19,958,400. Okay, so the next one I'm going to take you all the way back to your camping days. Remember how your mom would always buy those like 10 packs of those little cereals for camping? We even buy those for our kids now, just so we can keep the camping thing. And you have to get the popcorn, Jiffy Pop on the, those are 2 like, and the s'mores, so everybody goes to bed with marshmallow in their hair and on their hands on the sleeping bag. You must do all those things just to be able to, I think, function in society, right? I mean, if you're sitting around going, oh yeah, s'mores, you get it, and you're like, huh, what's a s'more? It's like, I don't want to hang around with you anymore, you weird. Okay, you need to go on. Okay, so let's talk about those little cereals, okay? Now, what were the cereals always left over? Raisin Bran, yeah. What else? Come on, think. Corn Flakes, definitely. Frosted Flakes wouldn't be last, right? But close to the end. Frosted Flakes first? See, it depends. See, and this is where it pays to be an only child, right? Because when you have brothers, they hide them, right? They'll put them someplace. They'll put them under their sleeping bag or someplace in the trailer. Or they get up before you and they eat them. And you knew that was your Fruit Loops because you already had one yesterday. Mommy ate 2, so then you're scrapping, right? And then, I don't know about your mom, but always had the rule we weren't allowed to open the next 10-pack until the crappy ones were gone, right? Like moms, they all get together, eh? And they're like, yeah. And they're like, oh, I love that idea. I'm doing that to my kids too, right? That's what they do. When you're at school, that's what they're doing. They're plotting against you right now. And that's one of the things they all come up with as a corporate group is do not open the next one till they eat that crappy one, right? And then you're like, you're even having 2 breakfasts that morning, right? Because you're getting rid of the crappy one, and then you get to have your Fruit Loops, right? Now, this is a question that I'm sure has plagued many of you, is how many different combination or permutations could I have of breakfast in the morning camping? All of you, I'm sure. Now, here's the first thing we need to know is how many boxes of cereal am I dealing with? So would it be 10 factorial? Do we have 10 boxes of cereal? So would 10 be the number of choices? Yes or no, you guys? Why not? No, but in mathematical, we still did 12. We divided by the repeats. There's not, what do you mean there's not the same number? In mathematical, there wasn't the same number of M's as there was A's. How is B different than this cereal question? Is it different? So, how many boxes of cereal? So, we've got 10 boxes. And now, do an inventory here. What do I got? So, you want to do this, you guys, so you can understand. Like, this is a really good exam or diploma question, right? It's reading. Everybody loves to read. And it's got tons of math in it. So, what else? 3 cornflakes. What else? Any more repeats? Are we good to go? Huh? 5 Raisin Bran? What are you on? Huh? Somebody talk to me here. How many? This one is supposed to be the hard part. 2 Rice Krispies, right? Where are you getting 3 Rice Krispies? It says 2 boxes of Rice Krispies. Okay, what else? Anything else? Okay, so the other ones, so how many Raisin Brans? So, how is there 3 Raisin Brans? Okay, so 3 Raisin Bran. Okay, so how would you do this one? 10 factorial over 3 factorial, 2 factorial, 3 factorial. Okay, and then I want you to do this, because that's totally wrong. Yeah, if you read the question, what changed this entire question from being like B? He says the first morning he will have Raisin Bran. So that gets taken out of the pool. Therefore, how many different boxes of cereal am I dealing with? So now it's 9 factorial, and what number down there changes? This changes to 2 factorial because Raisin Bran is taken out of the pool. Okay, so I mean, it's like a combination. If you tell me the first number of your combination, I'm not going to go, I don't care, and try and figure it out anyway, right? So if I tell you that I'm going to eat Raisin Bran the first, don't sit there. So what would you eat the first day? Okay, we're going to know that one. We're going to use that, okay? Then we're going to go on from there of all the different, okay? So the real answer is 9 factorial over 3 factorial, 2 factorial, 2 factorial. Yes. 151, those aren't question marks. 15120. Orders possible. That is how many days you would have to go camping before you had a repeat. Siblings changes probability a lot. I had 2 of the oldest, meanest brothers possible on the planet Earth, so I have a lot of surreal issues that I still have to deal with. Yeah, well, actually, you know what? My brothers were, I loved freezies, but my brothers weren't into them, so I was like the grape ones. Those I went for those ones for grape and blue and red. Those were the. Okay, now here's another. We used to have to do a lot of these in 30 Pure, and they've taken these out in great detail, I think. But how many ways can you move from A to B, and you must move closer to B every time? Okay? Now this essentially is like a repeat question. Because if you were to, like, a way is considered like a block. Okay? Like as in 1. So that would be 1, right? So this was 1 way, but the way that you can always find them out is, this is how I used to teach it, is you would put 1s all the way here. Because there's only 1 way to get to those places. Okay?
The following students, please come to the office at lunch. Jackson Peters, Arlen Peters, Lindsay Tuckaluk, Mariah Lofstrand.
Okay, so I want you to draw arrows because there's 2 ways to get to that point. Do you see there where I put the 2? There's 2 ways to get to that intersection. You could either go this way or this way. Now, how many ways to get here? You think about it, there would be 1, 2, 3 ways to get there, right? But what you do is you just add these two together. So you this, and you get 3. And then you could, this way and this way, you would get 4. So there's 4 ways to get to that intersection. Then what you do is you move down to the next row and you do these. This would be 2 plus 1 is 3. Then 3 plus 3 is 6. And 6 plus 4 is 10. Now, another way to do it is, I'm just going to erase all this. You've got it written down, but because these are my notes that are actually live right now. You count how many blocks it is from A to B. How many is that? Count. 1, 2, 3, 4, 5. Do it anyway. As long as you're getting from A to B, is there 6 ways, 4 ways? Is there another way that you can do it that's shorter? Try it. Or are you getting 5 every time? Okay, so it's 5 factorial divided by, how many downs are there? Like I'm saying 1, 2, right? Divided by 2 factorial. And how many rights are there? Because we're not talking about lefts or up, because you always have to be getting closer. You are not allowed, like this is like real life. Like this is the stupidest way to walk to school, okay? Unless there's like a big dog here or something, right? You're like, oh, I'm not going over there. But that's how we used to do these. We used to like, you have to drive from A to B, but this is a one-way going this way, okay? Or there's a park there, or whatever. So the way you do it is, it's 5 factorial is the number of blocks there, divided by 2, because there's, so 5 ways. And by 5 ways, I don't mean 1, 2, it's 1, 2, 3, 4, 5. No matter how you do it, it's 5 divided by 2 downs and 3 rights. So it's 2 factorial, 3 factorial. And you'll know, in any time you're doing your traveling ones, these two will equal the top number. And you will get 10 routes. Just like I did it doing the old way. Now again, in the last year we had to do these with one-way streets, with parks in the middle, and with parks in the middle you couldn't do it using, or we would have ones that would go like this, and then like this, and then like this, right? And you had, so they've taken, I'm pretty sure they've taken all these out of the curriculum. Now you just have to do, with nothing in between. Okay? So we're doing 1 to 8 and 10 to 12. So omit 9. Yep.